Hello once again. So we're on application of first order differential equation. So this time around, so we'll be covering problems so pertaining to interest. So interest is a special case of growth problem. Okay, so since if we have a certain amount of money and then we're going to invest it, it's either we're going to invest it on in a bank or on certain investment. So over a certain period of time, so the amount of that money is expected, of course, to increase. And interest problems follows. Okay, so the law of exponential change. The only difference this time is uh, the value of k, okay, so correspond for the interest rate already. Okay, so the value of k, so instead of needing another initial value, so for us to get the proportionality k, so if the interest rate is already given, so then k corresponds to the interest rate. So in this case, so we only find the value of c, or the arbitrary constant, so when time is zero. So usually when time is zero, that's the time that we invest money, or that is the amount of money that we put on a savings account, so in a bank. So to better understand, okay, so problem so involving interest, so let's have our first example. So when interest is compounded continuously, so the amount of money increases at a rate proportional to the amount s present at time t. So that is ds over dt is equals to rs. So where r is the annual interest rate. Okay, so the differential equation so pertaining to interest rate is given. So that is ds over dt is equals to rs. So wherein s correspond to the amount of money, so which is deposited in the bank, and then r so corresponds to the interest rate. So we are tasked to find the amount of money accrued at the end of 5 years. So when 50,000 pesos is deposited in a savings account, so drawing 5.75%. So annual interest compounded continuously. So in how many years will the initial sum deposited have doubled? Okay, so to solve this one, so we're going to write our given. So s corresponds to the s correspond to the amount of money at any time t. But then it says here that initially, okay, so 50,000 pesos was deposited in a savings account. So therefore, at time is equals to 0, so there is a 50,000, okay, so pesos in the bank. And then it draws a 5.75%, okay, of interest rate. So that means 5.75, so that would be 5.75. So 5.75%. So r is in decimal value. So we have to convert the percentage of 5.75. So by dividing it by 100. Okay, so 5.75 divided with 100, so that would make it 0.0575. And that is our interest rate. So for the requirement, so we need to find the amount of money at the end of 5 years. Okay, so at the end of 5 years, so after 5 years, so what would be that amount? And then in how many years will the initial sum deposited have doubled? So what will be the time? So initially, 50,000 was deposited, so double. Okay, so 2 times of the 50,000, so that will be 100,000. Okay, so for our solution, the differential equation is given, so which is ds over dt is equal to, it's already equal, rs. So therefore, we use separable equation. So ds over s is equals to r dt. So integrating it, that is ln s. is equals to RT plus C. And then to express this one explicitly, so we exponentiate both sides. So S then would be equal to CE RT. That's the same as the growth problem. So the only difference is we already have, okay, so the value for R. So what we don't have is the value of C. So that is why, so we start, so when time is equals to 0, so initially there is 50,000 amount of money in the savings account or in the savings account. So that makes it, so 50,000 is equals to CER, the time is 0. So E raised to 0 is 1. So therefore C is 50,000. And thus our working equation will be S is equals to 50,000 E raised to RT. Okay, but then we have our R, so which is R is 0.0575. 0.0575 multiplied with T. So therefore, so for our first requirement, okay, so this is our first requirement, that is when this one, so when time is 5, okay, after 5 years, so what would be S? So when T is 5, so what is S? So S then would be 50,000 E raised to 0.0575, and then the time is 5. So S will be, so 50,000 E raised to 0.0575 times 5. So that is around 66,652.53. So this will be the amount of money. Okay. So this will be the amount of money after. Okay, so after 5 years. So the interest, okay, so that you got from your initial amount for the savings account of 50,000, so the interest then, so you subtract it, so you earn, okay, so 16,652.53. Okay, so that's after 5 years. So given that the interest rate is 5.75%. For the second requirement, so when will it double? Okay, so we have initially it's 50,000. So the 2 times of that initial amount is 100,000. So when are you going to get 100,000 on the bank? So when S is 100,000, so what would be the time? So S is 100,000, is equals to 50,000. So E raised to 0.0575 times the time. 100,000 over 50,000 is equals to E raised to 0.0575 times time. So this would be ln 100 over 50, it's 2, is equals to ln of E raised to 0.0575 times t. So we take the natural logarithm of both sides. So that's giving us the time, so to be, so ln 2, so divide it with 0.0575. And thus t will be ln 2 divided with 0.05, so it will take 12.05 years for your money to double. And that's how money works. Okay? So once you invest it on a certain investment or deposited in the bank, so you deposit on the bank, so the lesser the interest will be. However, you are sure that you will get Okay, so what your money worth for. But then, if you want a higher interest, then most probably we can invest it on a certain investment. Okay, but then the risk would be higher. Of course, the higher the risk, okay, the higher the return. So let's have another example. Uh, Again, so a person places 5,000 pesos in an investment that accrues interest compounded continuously. Assuming no additional deposits or withdrawals, so from the investment, so how much will be in the investment account, so after 7 years. So if the interest rate is constant 8.5% for the first 4 years and a constant 9.25% for the last 3 years. Okay? So what will be that amount? Okay? So for my given, so let's say initially at times equals to 0, zero, 1, 2, 3, 4, 5, 6, 7. So this is from time 0, 1, 2, 3, 4, 5, 6, 7. So let's say at time 0, so you deposited 5,000. And then the interest rate, okay, so for the first 4 years, okay, so for the first 4 years, the interest rate is 8.5%. So for the first 4 years, so R is 0.085. And then for the last 3 years, so the investment, okay, so changes to, or it increases to 9.25. So R this time would be 0.0925. So meaning after 4 years, okay, so after 4 years, so there would be some amount of money, okay, that we can get. So that is after S4, right? And then after S7, okay, so there is another amount of money that we can get. Okay? So let's say the first money that you can get after 4 would be S sub 1. And then for the second distribution would be S sub 2. So that is the amount of money after 7 years. So in this case, so for us to find, so what would be the amount after 7 years? So we start with our given. So that is initially, so the amount of money is 5,000 pesos. So R is already given. So for the first 3 years, or for the first 4 years, it's 0.085. And so our R is there. So for our required, actually, so what would be the amount of money after 7 years? So for our solution, so we start with our formula, that is S is equals to CE RT. Then we start it that when time is equals to 0, okay, when time is equals to 0, so what happens? S is 5,000. So thus 5,000 is equals to CE, our rate, our rate is R, our time will be 0. So this would be 1, so therefore C is 5,000. So we can write then that our S would be 5,000 ERT. But then when time is equals to 4, so we don't know, so what would be our S? Okay, so when time is equals to 4. So that means that is our S1. Okay, so S1 then so will be equal to, okay, so 5,000 E, our rate. Okay, so for the first 4 years is 0.085. Then our time would be 4. So our S1 then so would be 5,000 E raised to 0.085. So multiply it with 4. And that is equivalent to 0.34. Okay. So that is the amount here. That is 5,000 This is 5,000, then e raised to 0.34. Okay, so that is our amount there. But then, so this amount, so this time, so after 4 years, so becomes the, this is now subjected to different interest rate. So this time it's 9.25%. So therefore, so we go back, okay, so we go back with our original formula. In this case, that is S is equals to CE RT. And this time around, the S1 will serve as our first year. Okay, so I'm going to make that one as our first year. So it will become, this is the 0 year, I mean. Then this is the first, the second, and the third. Okay. So for the 7 years, that is actually equivalent to the third year of the new interest rate. So now, I can start again. Okay, so when time is equals to 0, our S, this time would be the 5,000 e raised to 0.34. Okay, so for the new investment or for the new interest rate, our money, okay, it's no longer 5,000, but it is 5,000 times e raised to 0.34. So therefore, S then so would be, or S is 5,000. So e raised to 0.34 is equals to CE R times 0. So C is 5,000. So therefore, S then would be 5,000 e raised to 0.34, then multiply it with e raised to RT. But then this time, our rate is 0.0925 times t. So therefore, this time around, so when t is equals to, so for the equivalent 7th year, but this is the third year of the new interest rate. Okay, so 0, 1, 2, 3. It's the third year of the new interest rate of 9.25%. So even though we are asked what is the amount of money after 7 years, but actually that is the third year of the new interest rate. So that's when t is equals to 3. So what will be the value of S? And the value of S then so would be S equals to 5,000 e raised to 0.34, multiply it with e raised to 0.0925, so times 3. So giving us S to be 9,271.43. Okay, so that is how much your money will be. So if it is subjected to two different interest rates. So from 5,000, so it became 9,271.43. Okay. So interest rates or interest problems are easier type of problems. And that will be all for this video presentation. And I hope that you learned something. And again, good day and God bless.